At the end of this video, you should be able to solve the traveling salesman problem with the help of Hungarian method as an assignment problem. Traveling salesman problem is a kind of a famous problem in the field of operation research. In this kind of a problem, a traveling salesman is there who wish to visit the various cities and come back to the original city, but condition is that he should travel in such a way that the total distance traveled should be minimum. Now here consider that we have 5 cities and there is a salesman who wish to start from city A and come back to the city A. The distance between all the cities are known and all the cities are interconnected. Now he have to take such a path so that the total distance traveled will be minimum and he has to pay the minimum cost. Let us try to solve this kind of a problem with the help of one example. The problem statement given is as like this. A traveling salesman has to visit 5 cities. So A, B, C, D, E are the 5 cities. He wishes to start from a particular city, visit each city only once and then return to the starting point. The traveling distance of each city from a particular city is given in this following table. How should he schedule his touring plan in order to minimize the total travel distance? So let us assume that he take a random path and he start from A, go to B, then go to C, D and E. And the distance between all these cities is given in this table. So the distance between A and B is given as 5. The distance between B and C is given as 7. The distance between C and D is given as 8. Distance between D and E is given as 8. And distance between E back to A is given as 5. So the total traveling distance will be 33. But we are not sure whether this is the minimum traveling distance or not. Now if you want to calculate all the possible combinations like A, B, C, D, E or A, C, D, B, E, A, there will be 24 number of combinations which is given by this n minus 1 factorial, where n is the number of cities. So for 5 cities you get a 24 number of combinations. Now you can imagine how many combinations will be there for the number of cities, let us say 20. So we cannot calculate this kind of a problem with the help of this brute approach or calculating all possible ways. That is not a feasible way. So we will apply a Hungarian method to solve this kind of a problem. To solve this TSP, that is traveling salesman problem, with the Hungarian method, we will create this matrix. Now this A, B, C, D, E as at supply and these A, B, C, D, E cities are as a destination. Also, we do not wish that a salesman should travel from same city to same city, so we will allocate the cost of infinity at this point so that we can avoid any allocation for the salesman to go from the same city to same city. Also, the remaining cost or remaining distances between the cities is given and it is represented in this table. To start with the assignment problem, the first step is of row minimization. So for row minimization, we will select the smallest element from each row. For first row, smallest element is 4. For second row, smallest element is 4. For third row, smallest element is 6. For fourth row, smallest element is 4. And for fifth row, smallest element is 5. Now we will subtract this smallest element from all the element in the same row and we will write the answers in revised matrix. So the infinity will not make any difference. So 5 minus 4 will give me the value of 1. 8 minus 4 will give me the value of 4. 4 minus 4 will be 0 and 5 minus 4 will give me the value of 1. For second row, the smallest element is 4. So 5 minus 4 will be 1. 4 minus 7 minus 4 will be 3, 4 minus 4 will be 0, 5 minus 4 will be 1. In similar fashion, we can compute these values of third, fourth and fifth row. Now moving for the column minimization. Now select the minimum value from each column. So here it will be 0, for second column it will be 0, for third column it will be 1, for fourth column it will be 0, and for fifth column it will be 0. Now we need to subtract the smallest element from all the elements in that column and write down the answer in this new table. So infinity minus 0 will be infinity, 1 minus 0 will be 1, it will be 2, 0, 0. For this second column, again there will not be much change. Values of third column will be 4 minus 1, 3, 3 minus 1, 2, infinity, 4 minus 1, 3 and 1 minus 1, 0. Also for column number 4 and 5, it will be unchanged as the minimum value is 0. For making the allocation, the rule is we have to start from the first row and we have to search one row which is having only one unallocated or uncrossed 0. So if we scan this first row, we will get 1 0 which is not allocated or which is not crossed. So we will make our first allocation at this point. So I will allocate, or I will assign, I will make assignment at this point and I will cross all the zeros from that row or from that column. Now look for the second row, there is no uncrossed 0. Look for third row, there is a 1 uncrossed 0 available for making the assignment. So we will make one assignment at this point and there is no 0 in this particular row or column. Then we will go for the next row, there are 2 zeros. So we are looking for only 1 0, row with only 1 0. So there is no row with only 1 0. So we will scan the columns with only 1 0. So in this column there are 2 zeros. In this column again there are 2 zeros. In this third column there is only 1 0. So I will make allocations at this point. Now I need to make these 2 zeros as crossed. Now again I will start scanning the zeros from this column and I will get 1 0 at this point and I will need to cross this 0. Now you can see that we have made allocations. So we have made 1, 2, 3 and 4 number of allocations, but there are 5 number of rows and 5 number of columns. So we need ideally 5 number of allocations. Next step is to find out the minimum number of lines that will cover all the zeros. As this is the 5 by 5 matrix, we will need 4 lines to cover all the zeros. And to get those 4 lines, the procedure is like this. Identify the row which do not have any assignment. So this B row do not have any assignment. Look in this row if there is any 0. So at this column D there is 1 0. So mark this 0, or rather mark this particular column containing that 0. Now again look into this column and is there any row which is having the allocation. So this A row is having one allocation for this column. So I will mark this row A. Now there are no more markings are possible, so we will draw the lines. Now draw the lines through all the unmarked rows. So we have 3 unmarked rows. So row number C, D and E, and draw a line through marked column. So we have got this 1, 2, 3 and 4 number of lines which are covering all the zeros. Now if you look at the elements which are not covered by the lines, you will find that there is no zero. So we can say that the whatever procedure we have performed is the correct. Now the next step is to identify the smallest element from this uncrossed cell. So the cells which do not passing through the lines, we have to find out the smallest element, and the smallest element is 1, and we have to subtract this element from all the elements. So infinity minus 1, 1 minus 1, 3 minus 1, 1 minus 1, 1 minus 1, infinity minus 1, 2 minus 1 and 1 minus 1, and we have to add this element at the intersection. So this will become 2 plus 1, infinity plus 1 and 3 plus 1. Now let us update this matrix. Now I have put these infinity values beforehand because that is not going to change. So this 1 minus 1 will become 0, 3 minus 1 will become 2, 0 we have to keep it as it is, and 1 minus 1 will become 0. So again in the second row, 1 minus 1 will become 0, 2 minus 1 will become 1, 0 will remain 0 because we are not changing the values which are covered by the lines, and 1 minus 1 will become 0. So the elements that are covered by this line will remain the same, but the elements which are at the cross, at the junction of two lines, we are going to add the smallest element. So this will become 3, this will remain 0, 0, 0, 3, infinity plus 1 will not make any difference, and this 4 will remain as it is. So in last row, so there will be a 0, 0, 0. So this 3 plus 1 will become 4, and again that will be equal to infinity. Now we can make the allocations at this point. To make the allocation, scan the rows and identify the row which is having only 1, 0. So this particular C row is having only 1, 0. So I will make my first allocation over here, and I will cross out the zeros from that column. Now again look for the row which is having only 1, 0 which is not crossed. So there are no rows with only 1, 0. Looking in the columns, so looking in columns also you will find that, and in this particular column C there is only 1, 0. So I can make one allocation at this point, and I will cross these zeros in this row. Now again if you go to this row D, there are 2 zeros, and here there are no zeros. There is an already one allocation. Now as there are no rows or columns with only 1, 0 remaining for the allocation, we will select this particular row with 2 zeros for making allocations, and randomly we will make allocation at this point. So if I make this allocation at this point, I will need to cross these 2 zeros out, and now looking for the row with only 1, 0. So at this point I will get 1, 0 which is having only, at this point I will get 1 row which is having only 1, 0, and I will cross this 0 out. Now the only remaining 0 is, which is not allocated, is this B, D. So I will make one allocation at this point. Now here you can see that we have got 5 number of allocations, and each allocation is in a separate row and each allocation is in a separate column. So we can say that the solution that we have got is the optimum solution. Now let us verify whether it is possible for a salesman with this allocation to start from the city A and visit all the city and come back to the city A. So if we start from the city A, the allocation is at city B, so he will go to the city B. Now from city B, he will go to the city D, and from city D, he is coming back to the city A. So he is not completing the full path. He is only visiting to the two cities and coming back to the original city. So we cannot say that this is the solution for the traveling salesman problem. Now to get the solution for this traveling salesman problem, we have to consider the sales which are having least cost. So here we are making allocations at this 0. So but let us verify whether by making allocations at a minimum cost, so the next minimum cost is 1, by making allocations at this point, whether it is possible to complete the path. So we will try to make allocation at this point. So I will write this matrix one more time. We will make the first allocation at this 1, and accordingly we will make the remaining allocations. So making my first allocation at this point, so this will be crossed out and this 0 will be also crossed out. Now looking for the row with only 1 0, so in this third row I will get only 1 0, so making allocation at this point, so these zeros will be crossed out. Now looking for the row with only 1 0, looking in the columns with only one uncrossed 0, so at this particular column D I will get only one uncrossed 0, so I will make one allocation at this point and I will cross out this 0. Now looking for the rows, now you can see that I have two rows, that is row corresponding to this D where I have two zeros, and this is the row corresponding to E which is having two zeros. Even if I consider the columns, I will have two zeros in columns as well as in rows. Now at this point we have to make the allocations with a trick so that we can complete the path. If salesman is starting his journey from A, he will go to D. So from A he will go to D. Now from D, if we select this 0, he will come back to the A. So we will not select this particular 0 and I will make allocation at this point. So making allocation at this point, so I will have to cross this out, and the only remaining L0 for allocation is at this point, and I have a complete allocation here. So there are separate allocation in each row and there is at least one allocation in each column. So my traveling salesman will start journey from A and he will go to the city D. From city D he will go to the city B. So will go to the city B. From B he will go to the city C. B to C. From C he will go to E. From E he will come back to the city A. So here he is completing A, D, B, C, E, A. So he is visiting all the cities in this sequence, and thus we can get solution for this traveling salesman problem. Now Let us try to calculate the total distance he need to travel in this case. To get the total distance a traveling salesman travels, we have to refer this table which is given in the problem. So I have marked all the allocations from this table to this original table, and total distance will be given by this 4 plus 7 plus 6 plus 4 plus 5 is equal to 26. Now, if you remember, initially when we selected the path as A, B, C, D, E, A, we got the distance of 33, and this distance is quite small compared to the one we got earlier. So finally we can conclude that we can solve this traveling salesman problem with the help of Hungarian method as a assignment problem. Thank you.